Let's say we wanted to see what a quadratic looked like. We've been finding the vertex and moving a graph or doing all sorts of things like that. If you have a graphing calculator, you can have it graph it for you. If you click on Y1 in the upper left, you end up with a screen that looks like this. And I already had a function in there. You can store lots of functions at once in your calculator. The key thing to first realize is that you need to be very, very careful about how you enter things into your calculator. Your calculator is going to do exactly what you tell it to do. Do you remember how, you might remember, that there's a certain way of writing fractions that I like and there's a certain way I really don't like? Do you remember the way I do like? What's the way I do like? Do you remember? This is the way I do like. What's the way I don't like? The what? The diagonal slash, like this. Now, going between these two is actually okay because I'll generally understand it. But here's the problem. Let's say you wrote 3 over 4 plus x, which could be a function that you work with. We've worked with things like that before. If you translate that directly, sometimes you'll see people write this. I see this all the time. Is that the same thing? Technically speaking, that's 3/4 quantity plus x. If you put a parentheses around this, is this now the same thing? Yeah. Yes. The point is the calculator is going to do exactly what you tell it. And all the time people make mistakes. So for example, is that the same thing as this? No. No. Why is that not the same thing? Can you tell me why that's not the same thing? Harry.
Because the one on the right you're squaring negative x, and the one on the left you're squaring x.
Correct, exactly. So this is another, that's perfectly said. Another way to say it too is that this is always going to be negative and this is always going to be positive. Or what's the only way those could be the same? If x was 0. The only way it could be is x was 0, right? But at all other values, it's not the same. One of those parabolas faces up and the other one faces down. So when you enter your quadratics, make sure it's really carefully done. Okay, so going back to here, so let's say we want to graph one of these things. Let's say it was negative x to the 2. And do you see how the red is blinking? You can kind of see the buttons I'm pressing. Negative x to the 2. Let's say plus, what do you want? 2x minus 4. What button do you think you press to graph the function? You can either, if you press enter, you actually go to the next function. You can enter more than one. You can press graph. Graph is right here. It's hard to see. Graph is right there. You press graph. Now, you see how the equal sign is on right now? That means that it will graph this function. You can bring your cursor over to this equal sign and turn functions off. So theoretically, you could have like 10 functions here and just turn them on and off. Can you graph more than one at once? Absolutely. Will you need to do that in this class or other classes? Absolutely. Definitely. We haven't done more than one quadratic, but you could. So if we wanted to graph this, we're just going to press graph. This is the standard window that if you haven't changed it, this is generally what you'll see. This is zoom standard. This is zoom standard because it goes from negative 10 to 10 and from negative 10 to 10 on the x and y axis. Here's the thing. If you hit graph and you don't see anything, does that automatically mean you did something wrong? No. You could theoretically, I see this happen all the time. People make this graph, right? They go, oh, I have this graph. But then, instead of being on zoom standard or some appropriate window, like are all quadratics going to fit in that window? Could it easily be the case the quadratic is somewhere else? Absolutely. But sometimes people's windows are set like, literally this happens, they're set like here. So if you were just looking at that window, you would see nothing. You'd be like, oh man, something's wrong. So the first thing is make sure you enter your quadratic very carefully. And the second thing is it's sometimes going to take a little bit to understand what the best window is. So let's say, for example, you wanted to change the window. There's actually a button right here called, guess what it's called? Window. If you click on window, what do you see? The x min, the x max, the x scale, the y min, the y max, the y scale. Those are really the only 6 you need to concern yourself with. You should understand what x min and x max is. That's the furthest left and right. Y min and y max is furthest down and furthest up. What do you think the x scale and y scale are?
The lines that they go
yeah. So theoretically, could you want to like compress it a little bit if it's a really, really, really stretched graph and you don't really care about how fast you just want to look relatively nice? Yes. But generally speaking, what should your scale stay at? 1. Generally speaking, it should stay at 1. If you have it set differently, but you don't know it, you can make some really poor and analytical choices. Have you ever heard stories about people like lying with statistics or like cheating with statistics? Like they'll present a chart that looks like something's really, really fast rising, but what have they done? They've just compressed the x-axis, so it's like, it's rising really fast because it's steep. But then if you actually did it in like a normal way, There's other ways to lie statistics, like in bar graphs, people like cut off the bottom of the bar graph. So it'll be a column like this tall and a column this tall, right? So they're not that different, right, overall. But then people will cut off the bottom 90%, so it'll be just the top here and this. And so what does this look like? Looks like a huge jump, right? But it goes from like this to this. Just take a look at this. If anything's really strange, look at your window. And could we change this if we wanted to? Yeah, you can make it like, let's say, -2 to 3. Let's say I wanted to make it to 3. Let's say I graph this. What are we going to see? I should have hit graph. There we go. If I hit graph. Oh, look, it looks kind of strange, though, but you should key into that. It might actually be what you want, right? But what's the key thing to realize? It's stretched from -2 to 3 all the way from the left to the right. Now, if you wanted to get back to zoom standard, there's a button in the middle. What's this button called? Zoom. It's actually called zoom. If you hit zoom, you're going to do this many, many, many times in your math career because you'll be lost. You won't know what the window should be. There's 2 things in here. Zoom. Which one do you think is really, really helpful?
Zoom out.
Well, you can zoom out, and what zoom out will do is it'll zoom out from where you are, which can be, but which one do you think is really good? Just hit zoom and then 6, and it'll center at -10 to 10. Now, you'll notice one thing. Is the graphing calculator window a square? It's a rectangle, right? But it's stretched. So is this a little bit stretched?
Yeah.
It's a little bit stretched. I forget what the resolution is. It's like 84 by 120 or something like that. There's actually another zoom. If you want to know what this really looks like, if you hit zoom, which one do you think is a really good one to try?
Zoom square.
Zoom square. What zoom square does is it changes the scale, so it's kind of like it's a little bit better. The idea, though, is the graphing calculator going to give you some perfect graph? No, the resolution of this calculator is identical to the one that I used in high school. And I'm old enough to be able to be surprised by that, okay? What's very interesting, there's certain pieces of technology that just haven't changed. Fax machines, graphing calculators. They're slowly changing, but the graphing calculators are kind of going to go the way of the dodo. Do you understand what that phrase means? Why?
Oh, they're going to be extinct.
What?
They're going to be extinct, right?
They're going to be extinct, exactly, yeah. Why are graphing calculators going to be extinct? You know the answer to this. Be more specific. They're computers, yes, but specifically. What? Whatever device you're carrying around with you, right? Like the device most of you have in your pocket is way better at doing these things with certain apps than your graphing calculator is. We haven't really solved the communication issue, which is like if you actively use them too much, it makes it too easy to cheat, even maybe not intentionally, like looking stuff up that you think, oh, I can look this up, I have access to it, right? That's the problem. But the idea is a standalone device to do one thing. That's kind of a weird thing in today's world. What are we more moving towards? Lots of things being done by one device. Yes, Eric? There's tons of them. There's tons of really good ones where you can like push them around. So instead of zooming by specifying numbers, you can literally just zoom in like you are accustomed to, right? You can do colors and all sorts of things. There's really good free ones and there's really good pay ones, right? The idea though is we need a standard device right now, and the tests we have designed are very much calculator or no calculator. That being said, there are ways to design tests where it doesn't matter if you have a calculator or not. We're just not quite there yet. But think about it. This device, I'll pull one out in a second, the graphing calculator, it's very strangely kind of a device out of time, at least in my opinion. Okay, so what I've shown you right now is to graph one of these things. Button. If I hit the trace button, it gives me x. It says x is 0. You see that blinking cursor that's there? It's blinking on the y-axis right there. If I move left and right, look what it does. It tells you the value, but is it really fine? Not really. If you want to get better values, you'd have to zoom in. Do you understand? So this is good for getting estimates. Do not rely on this to give you final answers. There are very specific ways to get exact answers. But can this be really helpful? Sure. Like if you go right here, if you go right, if you go left a little bit, I'm going left. What am I getting close to?
You're just pressing the left arrow.
The left arrow. That's correct. What am I getting close to, Aubrey? The vertex. So can I estimate the vertex?
Yeah.
If you had to round that, what does it look like the vertex might be?
X1,
1 and -3, right? It does look like it, and you could test that, right? You could try to find it exactly, but is this a good way to get a quick estimate of points? The key thing here is trace. Don't use it for exact answers. Only use it for estimates and only use it for answers when you're specifically told to. Like I might give you an ugly function and say use the trace feature, right? As a side note, let me show you one more zoom option. This is a really cool one. You see zoom box at the top? Watch what happens. You hit enter and select zoom box. It gives me a cursor here which I can move anywhere. I press enter in one corner And then look what happens as I move the cursor. What's it dragging out? Do you see that, everybody? So what it's allowing you to do is zoom box like that. So if it's hard for you to estimate what the window would be, if I hit enter in the upper left and enter in the bottom right, you can do any diagonal corners. If I hit enter right here, look what happens. It picks that window, and what does it do? It zooms just that part of the graph. Why is that kind of helpful if I'm using trace? Exactly. So if you really just want an estimate, you could then hit trace and see where the cursor is. Does it really look like it's about that exact value? Yeah, it looks like it's 1, 3. But again, is that a way to get the exact answer? No, it's not. Just key realization. Okay, so everybody, graph that function and pick a window that you think makes the function look best. Okay? I want you to play around with zoom so that you can see this function in a way that you think looks best. So should you zoom in too far? No. Should you zoom in too far in? No. Or out? No. Find a window, and then I'm going to ask you what that window is. So you play around with it. So it's negative 3x squared minus 9.6x minus 1.38. Is this the window you have? Yeah, I mean, it's going to might look a little different, right? The point, though, is there a lot of empty white space in there?
Yeah.
So what if you wanted to change something? Let's change the x min and x max first. What x minimum do you want to use?
I just a min.
Yeah, what's the lowest x value do you want to have up there? It looks like it's too far to go to negative 10, so let's shave it off a little bit. Negative what? Well, let's take a look. Let's just sketch what we think it would be. Hold on. If we wanted to sketch what we think the window should be, we're looking at just x right now. So if I take this right here, we graphed it like this, right? This is what it looked like this. We want to, like, if we wanted a better window, we might want to, like, take it from, let's say, here to there. Those are the y values, and then maybe like this, right?
I'm choosing -5.
Yeah, and what do you want? What do you want over here? Like 2. So maybe 2, -5, and then what? Like what down here do you want for y min? Negative. What does that look like? -5. And then up here, how high should we go? 1, 2, 3, 4, 5, 6, 7. 1, 2, 3, 4, 5, 6, 7, 8, maybe. So if I change this window, so what did we say? X minimum of not -10. We got -5. And x max of what? 2. An x minimum of -5. And a y max of what? 8, did we say? If we graph this, theoretically, should this look maybe a little bit more pleasing?
Yeah.
Oh, does that look a little cooler?
No.
Yeah, I mean, you don't want to go too far. Do you need some space around it?
Yeah.
If you don't have some space around it, when you start moving a cursor around, it'll get cut off. And that's really annoying. Okay, so if we wanted to estimate the vertex of this graph quickly, what function could we use? Trace. So use the trace. Don't tell me what it is, but use the trace on this graph and estimate for me. You could write it down. When you traced it, your cursor should blink up there. Or sometimes your calculator, it's weird. I don't know where it chooses to put the cursor initially. Sometimes it'll be way down. I think it's based on maybe what you did last, I think. But here's one thing to be careful of when you trace. Sometimes you hit trace and you'll be like, where's the cursor? I can't find it. Check the x value. Sometimes it puts the cursor off your window. So sometimes you're like looking here and you hit trace, and where's the cursor go? Like down here. So you have to hit right, and then all of a sudden it'll pop up. So is that where the vertex is, where that cursor's blinking? No. So I move left a little bit, I move left a little bit, I keep going. So if I want a quick and kind of dirty way of estimating the vertex here, how's that for an estimate of the vertex? Looks not bad, right? It looks not bad. So if I did this here, we zoomed in and we're doing the trace here. So if I wanted to round this to 3 decimal places, 3 decimal places is a really key rounding. What would the vertex be if we rounded this? Negative 1.649, comma, 6.293. If we round it up. Generally, there's 2 ways to round. Do you know about the 2 ways to round? So when we get to the 8 here, 9 is greater than 5, is 5 or greater, so we make this a 9, right? But another way to round, which is super common, is just to chop off anything after 3 decimal places. On the AP Calculus exam, they accept either one. I just want to prepare you for that. 3 decimal places. If I ask you to round, you go to at least 3. So if it's zeros, add zeros on. So did we estimate the vertex?
Yeah.
Getting a vertex like that, what does it tell us about factoring this? It might not be really nice. It's a strong indicator when you have an ugly vertex that the factorization is going to be really ugly, right? And that probably means using your calculator was really great. So looking at your graph, does this open up or open down?
Down.
Opens down. How could you get that without even looking at the graph? If you had the function, It's a negative leading coefficient, right? Okay, if I wanted to list the axis of symmetry, can someone tell me what function, it's a line, can someone tell me what the axis of symmetry is? Where does the axis of symmetry pass through? Yeah, this is your axis of symmetry right here. What's the function for this line right here? What's the function right there? Nope. X is equal to what? Yeah, exactly. This is x is equal to negative 1.649. That is the axis of symmetry. So we were able to find the axis of symmetry because we had the vertex. But how did we get the vertex? Using our calculator. What are some other there are three other interesting points we would love to get on this graph. What are the other interesting points we would love to be able to get on this graph? The x-intercepts would be awesome. We know, though, or we suspect that because the vertex is ugly, that probably means the factored form is ugly. So there's a function on your calculator. Everybody put your calculator down. I'm going to show you this really cool function. You ready? If you go to above the trace button, you see there's some blue words up here. If you ever want to key in a blue word, you use the second button. So watch this very carefully. If I hit second trace, it's executing the calc feature, second calc. There's some really, really important, this menu right here overall is probably like the coolest stuff that's overall the most helpful for you in like all of your math career. On the AP Calculus exam, 90% of what you need the calculator for are two functions on this that we don't use. It's 6 and 7. We don't use that because you're not in calculus. Which function do you think we want to use here to find the x-intercepts?
Oh, no.
That's a really good, hold on. That's a really good guess. Intersect is when you have more than one function and you want to find out where they intersect. How many functions do we have? One. Which one do you think do we want? 0. Watch. It's just, they create a short name. It means the zeros of the function. Zeros are the x-intercept. So if I hit 2 right here, what's it asking me for? How many zeros can a function have? How many could it have? How many times could a function cross the x-axis? An infinite number, right? You could have a function just going up and down, right? So what it's asking you for, it's asking you for a left bound. What do you think that means?
The farthest left to go.
The left, kinda. What it's asking you for is it needs to know what area to look for the zeros in. It's going to look for them one at a time. So it wants you to say which one do you want. You go to the left of one of them, and what button do you think you press? Enter. And what do you think? Oh, look, what does it ask me for now? Where do I go? I'm going to go to the right here, to the right of that 0, and what do I hit? Enter. Oh, it asks you for a guess. So where do you go if you guess? A little bit to the left, right? Hit enter. It goes doot, doot, doot. Oh, look what it gave me right there. Look what it gave me. Where's the cursor? Where does it look like the cursor is actually at? It looks like it's at the x-axis, right? So you look at those, well, does it look kind of like it's on the x-axis? Yeah, it does, right? Again, is this super high resolution? No. So you have to decode what it just gave you. It gave you a 0. The 0 is where it crosses the x-axis. The function crosses the x-axis when y is equal to what? 0. When y is equal to 0. Now, this doesn't look like the number 0, right? What does e mean? Anybody know what e means on the calculator? 10 to that power, right? This is -1 times 10 to the -12. What is that really like super, super, super close to?
0.
That is 0.000000000000001. Well, it's like negative, right? So is that effectively 0? Yes. So what is our first x-intercept? Exactly. Okay, so this is what I'd like you to do right now. I would like you to find me to 3 decimal places what the other one is. What is the other x-intercept? And remember, it's second trace, which executes the calc command on your calculator. The calc command. Where do you place it? This is what I mean. So if this is the graph you're working with, Harry, it's a very good question. It's a little bit unclear. For your left bound, pick any point. I would pick bring your cursor like right here. Any of these could be your left bound. And where should your right bound be? But like down here, right? And then where should your guess be? Somewhere in the middle, right? You'll see a little cursor come up when you've selected the left bound, and you'll see a little cursor come up here when you've selected the right bound. Your guess needs to be in between.
Then will the opposite be for
Correct. And it'll be the left bound will be down here on the right bound. It has to be to the left and to the right of the 0. It doesn't matter if it's above or below the axis, because you can either cross like this or you can cross like this. So did you guys find what that point is? Someone find the x value there?
Yeah.
What'd you get, Aubrey?
I got -0.151.
Who got -0.151? Yep, that's great. There's only one thing you could do on that decimal that would be kind of helpful just to me when I'm reading your work. Make it -0.151, comma 0. Put the 0 in front of the decimal. It doesn't change much. If you're writing neatly, it's okay, but I really like that 0 there. Okay, duplicate that right now. Evaluate the y1 function. So it's vars. I know, you have to get used to it. Vars. Y vars. It's right here. Look, vars is right here. Vars.
Okay.
Are we doing the second function?
The second function? No, just hit vars. Nope. So vars, y vars, function y1. Function y1. And what are you entering? Y1. You don't have to do the 0, but you want this right here. And what do you end up getting when you do this?
Yeah.
You should get that right there. Raise your hand if you got that right there. Talk about.
Thank you.
Next thing we're going to talk about is give me a random point, Liv. Any point, any x value.
3.
3. Give me any x value, Emmett. Any x value. Oh, make it a y value. If I get 5, sure. 3, 5. I'm going to do a -2 and I don't know, 4 point. Let's say -2, comma -3.98. Let's say a 3. How many? Let's see, another point. Aubrey, give me any value. Favorite number.
8.
8. Okay, 8. That's fine. And how about -6.25? Those 3 points, there's a parabola that goes through those 3 points. Theoretically, could you graph the parabola by hand? Yeah, you could graph those points and then you could estimate it. Guess what your calculator can do for you?
Just do it.
It can give you the parabola that best fits those 3 points, which is really cool and helpful. Many real-life situations are modeled by quadratics. Sometimes you have a few points of data, but you want to predict another one. If you want to make a prediction, what do you need? You need the function itself. You need the parabola. If I just give you 3 points, have I written the function that these 3 points come from? No. But let's say I wanted to know, hey, what happens if it's 9? Well, we could kind of guess if we made a sketch, but would it be really useful to know exactly what it should be? Now, if I gave you 2 points, can you find the slope between those 2 points? Okay, you can be more confident than, yeah. Okay, how many of you could find the slope between 2 points? Raise your hand. Everybody raise your hand. You all can do it. Have confidence. Now, finding the equation of a line is pretty straightforward. Finding the equation of a quadratic, can it be really annoying? Yeah, it can be really annoying. So what are we going to use to find the equation of a quadratic? Calculator. So what do you think the first thing you need to know how to do is if you're going to use these 3 points in your calculator? What do you think the first thing you need to know how to do is? You're going to ask your calculator to find you the equation for the quadratic that goes through these 3 points. So what do you think the first thing you're going to need to tell the calculator is?
Points.
The points, right? So your first step, no, don't do it yet. I'm going to show you, and then you're going to start twitching with your little devices. The first thing you need to know how to do is put these points into your calculator. You ready to learn how to do that? Okay, so watch carefully. When I bring the calculator back up, there is a button here called Stat. The Stat button is right here. You can look at your calculator. Don't touch, just look. Stat button's right there. You see this Edit button right here? If I hit Stat, and then I hit Enter on the Edit button, look what I'm at, L1, L2, and L3. Don't press anything. You're going to get, I'll show you how to clear this later, right? Sometimes you might have values in there, but you need to clear it. List 1, list 2, you can have X values and then Y values. So let's go back and look at our X values. What were our X values? 3, -2, and 8. So I'm going to put 3, Enter, -2, Enter, and what? 8. So I hit over to the right here. What were the Y values? 5, Enter, -3.98, Enter, and what was the last one? -6.25. Does it matter what order I put the points in? Does it matter if can I scramble these but not scramble these? No. 3 needs to be next to 5. Negative 2 needs to be next to this, but does it matter what order I put the rows in? No. Points are points, right? It doesn't matter if you graph it first, second, or third. It's still going to be the same graph when you're done, right? But does it matter that these correlate, like 3 goes over to 5? Yeah, because if you switch it, it's a different point of view, right? Do this for me right now. Get this up on your screen right now. You hit Stat, and then Edit. This is the screen that I want you to get. Stat, and then Edit. We ran into this with entering the functions. Could there be more than one list here? Yeah. So when you're entering these lists, it's really good to remember. Make sure you clear out all of the values. It can be really, really confusing if you don't. It can be really, really, really... What direction is this parabola going? How many people agree it goes down? The vertex is somewhere up here, right? The x-intercepts are somewhere here. You know a good deal about this. Now, if you want to know it exactly, everybody hands up, watch how you do this. On your calculator, above the, when you go to y equals, what you're going to do is you're going to clear, don't do it yet, but you're going to clear the function there. And do you see the plot 1, plot 2, plot 3, and plot 1 and plot 2? You go up to plot 1 and you hit enter, and since it's highlighted, plot 1 is turned on. If it's highlighted, it's on, okay? Above the y equals button, take a look at your calculator. Don't press it. There's a stat plot. Raise your hand if you see stat plot on your calculator. Or Milo, the calculator on your table. Look at it. Do you see stat plot right there? How do you do one of the blue functions? Second stat plot. So watch what happens. It gives me some options. I'm going to turn it on. I'm going to press enter. Do you see how it has to be on? So plot 1 is on. We want dots. And you can choose what type of point you want. I like this one right here. That's my favorite one. But you can choose the other ones if you want.
You want dots, not the one.
I don't want it. No, we're not connecting them yet. We're just, what we're doing right now is we're just plotting the points. We're not actually doing the graphing function thing yet. Okay? Turn it on. You can hit.
Did you do second what to get that?
Don't. It's second y equals. Don't do it yet. See, it says stat plot. Okay. If I now have these on, these are just options. I'm going to go out of here. If I go back to y equals, everybody, you see how plot 1 is turned on? I'm going to zoom. Which zoom do you think is really going to be helpful? If I go to the top here, you see all these zooms here? These are not super helpful, but which zoom do you think is really helpful? I'll give you a hint. Zoom stat. What do you think zoom stat does? It zooms to fit the data you're using. So if I hit enter right now, look what it does. Cool. Did it just plot those 3 points? Now, do those 3 points look vaguely like the ones you plotted? Yeah. They do. They really, really do. So this is what I'd like you to do. On your calculator, see if you can make it look like that. On your calculator, see if you can make it. If I quit to the main screen, I'm going to show you something really cool. Second quit, sorry. If I go to Stat, Calc, which one do you think I'm going to choose? Take a guess. Stat, Calc. So I did Stat and then Calc and moved over to Calc. Which one do we think we want to use? Quadreg. That means quadratic regression. What number is that? Harry, can you look up for a second? Thank you. If I hit 5 and I hit enter, look what it does. Whoa. What did it just give me? It just gave me its best estimate for what this quadratic should be. Now, what did it tell you? A, B, and C. So I'm going to show you. So again, I'm going to clear out the screen. If you're on the main screen of your calculator and you hit Stat, go over to Calc and 5. Stat, Calc 5, Quadreg. See if you can get this to come up on your calculator. This is what you're looking for right here, everybody. Quadratic regression. See if you